right, so derivative of the top, so we'd write that as d dx of f of x, just another different notation, times g of x. Oh, I'll put the g of x in front. Do you have room to do that? G of x times the derivative of f of x minus f of x.
Daniel Eliza, please come to the office. Daniel Eliza.
It's your brother. It's your brother. Times d dx, so the derivative of the bottom, g of x, all over g of x squared. It's just notation, so obviously I really like writing the primes because it's a lot more condensed, but right, d dx of f of x is still the same thing as f prime, finding the derivative of f of x. So stated in words, derivative of the top times leave the bottom minus, sorry guys, leave the top thanks. I like this one. Great? Yeah? Okay, no? Okay, the other one, low d high minus high d low, draw the line and square below. Huh? I like that one. Okay, we're going to write that. Do you want me to write both? We could. Low d high. I'm going to write d so you can pronounce it right. Low d high minus high d low. Draw the line and square below. You'll notice that I'm giving you all these little sayings. It's not on your formula sheet, the quotient or the product rule. Okay, so you need to know this. As you practice, it's really easy. Derivative of the top times the bottom minus, leave the top times the derivative of the bottom over the bottom squared. Okay, oh, I lost my, draw the line and square below. Low d high minus high d low. Okay, another saying do you want me to write the other one, the ho d high minus high d ho? Okay, all right. No, no. It's really the same thing. Instead of using low, they're using ho. Because then you get to say, high d ho. And then all over ho ho. Or you could do draw the line and square below. Okay. All right. Over x squared minus 1. So differentiate means find the derivative. Okay. So if we're finding the derivative here, we're going to use we're going to treat the numerator as our f of x and our denominator almost as our g of x, or our high and our low. So the derivative, f prime of x equals, who do we differentiate first? The top or the bottom? Low d high, the top. So I like to just go derivative of the top. What's the derivative of the top? 1 times, leave the bottom, x squared minus 1, so times by the bottom, minus the top times the derivative of the bottom. So top is x, times the derivative of the bottom is 2x. All over what? Draw the line and square below. So square, we have x squared minus 1 squared. Let's simplify this, because we can. What? We can. Okay, so the numerator, let's simplify the numerator. Minus 1, we really didn't need to write the 1 there. Take away 2x squared. X squared minus 2x squared, negative x squared, And then we have a minus 1 all over x squared minus 1. Now, if I factored out a negative, could I get an x squared minus 1? No, so there's no point in doing that. We are done. Not so bad, right? No, leave it in squared form. Yeah. Okay, let's look at this. Oh, I hate when you do that. No. Sorry, guys. I'm having a little bit of a temper tantrum. There you go. Stay. Yes. Okay, they give a whole bunch of information. They want us to find f of g, f divided by g prime of 2. Okay, so we know the formula. What's the formula for the derivative of f over g of x? We have that up above, right? Let's just write the simple. Can we write the simple formula? Yeah, derivative of the top times the bottom minus, doesn't matter the order. I like to go the top, doesn't matter. Top times the derivative of the bottom all over the bottom squared, g squared. Okay? Now we could put 2 in there. Hey, Wes, put that away. Your name is forever on this recording. Ooh. Okay, we could have also wrote this as f prime of 2 times g of 2 minus f of 2 times g prime of 2 all over g of 2 squared. Right? Yeah, we can go straight to substitution if you want. So really, what's f prime of 2? Because we want it at x equals 2. 3. So 3 times, what's g of 2? 6. Minus, what's f of 2? Negative 4 times, what's g prime of 2? Negative 2 all over what squared? 6 squared, g of 2 squared. We have 18 minus 8 all over 36, or 10 over 36, or 5 over 18. Easy. Oh. Okay. What's the domain? Oh, thanks. X has to be greater. Can it be equal to 0? Yeah? Yes, it can. Is there anything it can't be that's greater than 0? Then it can't be 9. So it can't be negative, because you can't take the square root of negative. It also can't be 9, because then you'd be dividing by 0. So if we were to write this in, how would you write this in interval notation? Comma, 9, union, there you go, you guys got it. Beautiful. Okay, so now let's differentiate this puppy. Do you want to try it yourself or do it together? Yourself? What would we have to do with this function? I might want to do right off the bat. Write our exponent as the square root of x as what? 1/2. X to the 1/2 in exponential form. Okay? All right, we want to find f prime of x, so the derivative. Okay, where do we start? Derivative of the top. So what's the derivative of the top? 2x times, no, times derivative of the top times g. So g is Root of the top times the bottom. Derivative of the top times the bottom. Just leave the bottom, times it by the bottom. And then less, or minus, the top times x squared times the derivative of the bottom. What's the derivative of the bottom? X 1/2 x to the negative 1/2 all over. Are we going to simplify? Yes, we are. All over the bottom squared. I'm going to write it in original form. Okay, let's simplify the numerator. Okay, so we're going to use some distributive law. Now this is fun because, yeah, if I have 2x times x to the 1/2, no? 2, what's x times x to the 1/2? What do we do with those powers? 3 over 2. We add them. 1 plus 1/2, or 2 over 2 plus 1/2 is 3 over 2. 2x times negative 3, that one's easy. Minus 6x. All right, minus, we have 1/2. And then x squared times x to the negative 1/2. What is x squared times x to the negative 1/2? What are we going to do with those powers? Add them. So 2 plus negative 1/2, 3 over 2. Cool. That's cool. Why is that cool? Like terms, yes. All right, what's 2 minus 1/2? Again, we just did that. 2 minus 1/2 is 1/2, or 3 over. All over root x minus 3. Okay, remember pre-cal where we factored? Where we factored out fractions and where we factored out the smallest power? Somebody? No? Yeah, we did that. Okay, so here, first of all, if I want to factor out a fraction, what would be the common denominator we'd need here? 3 over 2 and then minus 6. Yeah, over 2. We want 6 over to be over 2. So 12 over 2. We're going to make it a fraction, the common denominator, to factor out the 1/2. Well, we could actually factor 3 over 2 out of this. Okay, so let's just rewrite it again. You guys really struggled on your test with factoring out the fraction. So let's review that. We want to make them both the same denominator. Okay? There you go. Okay, so now the numerator, what can you factor out of the numerator? A 3, and then denominator we can factor out a 2. So 3 over 2, what's the smallest power? X. We're going to factor out an x. Yay. Okay, so when I factor out an x from 3 over 2, what are we doing? How do I get? We were minusing 1, right? A power of 1. 3 over 2 minus 1? 1/2. And what are we left with here? We took out a 3 over 2. So I took out 3 from 12. What do you have left over? 4 over, no, the 2 we pulled out. Just a 4. Just a 4 over 1. Because we pulled out a 3 from the numerators and a 2 from the denominators. We took out the 3 over 2. Okay? All right. We could rewrite this. So this 3 over 2 is kind of ugly. So I'm going to keep the 3 on the numerator. The 2 moves to the denominator. So our final answer in simplified form, 3x times root x minus 4 all over 2, so I move the 2 to the bottom, times root x minus 3 squared. A little prettier. Because the 3 over 2, you put it out front. It's the same thing. By 1. Just by 1. It's still just 3 over 2. So you can move the 2 to the denominator. Right? This could also be put out front. It's 3 over 2. Yeah, it's weird. Okay, yay, turn the page. Ooh. Show that there are no tangents to the curve y equals x plus 2 over 3x plus 4 with positive slopes. Okay, what does that mean? First of all, tangents to the curve, what is that really talking about? What are the tangents to our curve? The derivative, right? There are instantaneous slopes. So that's the derivative. We want to prove that our derivative is always what? Negative. Our derivative is always negative. That's what we want to prove. So in order to prove that it's always negative, that our derivative is always negative, we have to start by taking the derivative. Can you please, on your very own, find the derivative of this function? Okay, so our y prime equals, derivative of the top is 1 times the bottom minus, leave the top, times the derivative of the bottom is 3 all over the bottom squared. You simplify the numerator. We have 3x plus 4. When I bring in the 3, I have minus 3. I have to bring in the negative and the 3. So minus 3x, take away 6 all over the bottom squared. Okay, so the numerator you have left with just a negative 2 all over 3x plus 4 squared. Why does this prove that our derivative is always negative? Yeah, Aaron? Pardon me? You're on the right track. Yeah. You're dividing a negative by positive. Yeah. So the numerator is always negative, and the denominator is always positive because you're squaring it. And so a negative divided by a positive is always negative. So therefore, since negative divided by positive equals a negative. Assuming f is a differentiable function, find an expression for the derivative of the following. Okay. Y prime. How would you write the derivative of f of x? F prime of x. So f prime of x times the bottom, so derivative of the top times the bottom, 4x squared, minus derivative of the bottom is 8x times the top we leave the same, f of x, all over 4x squared squared. If you want, you can simplify this. I probably would. So what can we do to the numerator? Is there anything we can factor out? 4x. We can factor out a 4x. We're left with, I'm just going to move this to the front. If we factor out a 4x from 4x squared, what are we left with? X. So x times f prime of x minus, if we factor 4x out of 8x, just 2 f of x. And when you square 4x squared, what does that equal? 16x to the 4. Can something be simplified here? Yep. Now that it's in factored form, we can reduce this. Okay, so the x is going to reduce and the 4. We can divide both of those by 4. So we have 4x cubed on the bottom. Cool? I wanted to add an example. Did I add it in there? Yeah, you don't have to write it all out. 2 tangent lines to the curve. Y. Okay. So there's one more example that we're going to do. And it says 2 tangent lines to the curve y equals x squared plus 3 pass through the origin. We kind of done this kind of question before. Should have made it more interesting. Oh well. Did you want to try the question while you're waiting? No? 2 tangent lines to the curve y equals x squared plus 3. So you can do a sketch while you're waiting. Can you please sketch this? Pass through the origin. Find the coordinates of the points where these tangent lines meet the curve. Okay, if y equals x squared, we're going to shift it which way? We have graphing y x squared plus 3. 3 up. Yeah, 3 up. So your sketch should look like 1, 2, 3. There's our graph, y equals x squared plus 3. Okay. What else do we know? Our tangent lines go through 0, 0, the origin. Okay. So we have 2 tangent lines. Let's make them green. Going through 0, 0. We want to find those points. Oops. Points that on the curve. Okay. So how could we start this one? So 2x. So the derivative of our function, we know the slope at any point is equal to 2x. Okay, so that's our slope, our instantaneous slope at any point of our tangent lines is going to equal to 2x. What else could we do? That's where I'd probably start. Is there another way we can find of our lines, of our tangent lines? Y minus y1. What is this point going to be here? X, comma, our y value is x squared plus 3. So our tangent slope is also equal to y2 minus y1 over x2 minus x1. Or y2 minus y1, so x squared plus 3 minus 0 divided by x minus 0. Or x squared plus 3 over x. So that's another equation for our tangent line. Our slope. So what can we do now? Set them equal to each other. Okay, so solving for x, first step. Times x to both sides. Yeah. Gives you 2x squared equals x squared plus 3. We're solving a quadratic, but it's a simple quadratic. So subtract x squared to the other side. X squared equals 3. So that means x is, when you square root both sides, that means plus or minus root 3. So we're square rooting both sides. And we want the actual points. Okay, so we know one point is going to be negative root 3 comma something, and the other point would be positive root 3 comma something. How do I get the something, the y value? Plug it into where? Should I plug it in here? No, that's the equation of our slope, the actual equation. Okay, so negative root 3 squared is 3 plus 3, 6. Positive root 3 squared is 3 plus 3 is 6. So we plug it into always the original equation to get the y value. The derivative gives us our slope, not the y value of our line. All right, that is our lesson. Okay, yeah. So stop the video.